All right, guys, welcome to Properties of Equality and Congruence. This is when all our if-then statements meet mathematics. So we have a ton of properties. A lot of these are going to make a lot of sense just naturally, okay? Addition, subtraction, multiplication. You're just going to get it. And this is another way to say it. This is just a proof of why, okay? So, for example, the addition property of equality. For short, I tend to say POE, property of equality. So the addition property of equality says that you can add something to both sides and it will remain the same. So if A equals B, then you can add something to both sides and the equation remains the same. So it doesn't even have to be, okay, so if x equals 3, then x plus 2 equals x, 3 plus 2. All we did is add something to both sides. That is the addition property of equality. Subtraction, same idea. So if x equals 3, then we know that x minus 2 is the same as 3 minus 2. As long as you were adding the same thing to both sides, or subtracting the same thing from both sides, right? Plus c, minus c, minus c. That is the subtraction property of equality. Multiplication, same thing, team. If x equals 3, then x times 2 equals 3 times 2. So sorry for that horrible noise. Division, same idea. If x equals 3, then x divided by 2 equals 3 divided by 2. If you divide both sides by the same number, it remains the same. All right, we also already know the distributive property of equality. If A times B plus C is going to be equal to A times B, C times B. Y'all, this is another version of the multiplication property. You're multiplying the same thing by both of these, but distribution. So if 3x plus 2, then 3x, that equals 3x plus 6. Okay, it is the reason we can distribute that 3. Substitution. If A equals B, then A can be replaced by B in any expression or equation. So if x equals 3, and I have like x plus 2 is going to be the same as 3 plus 2. I can substitute in x, 3 for x, okay? You can replace it. You can substitute it in. Whenever I have a sub, they are taking my spot temporarily. Reflexive. If you have a reflection in the mirror, your reflection in the mirror just shows you that A equals A. Y'all, it's the idea that like x equals 3 and 3 equals x. That is the reflexive property. It's the same thing. Oh, snap. Miss Mayhew, you put it in the wrong place. Reflexive property is just obvious. A equals A. 3 equals 3. X equals x. Symmetric property shows symmetry. Symmetry means that it can be flip-flopped and it's still true. Symmetry means it can be flip-flopped and it's still true. So like if I have a perfect circle, well, I can't draw a perfect circle, can I? I can flip-flop these two sides. It's still a smiley face, right? Symmetry, lines of symmetry. So that's the one. If x equals 3 and 3 equals x, they're the same both ways. Y'all, it's still an if-then statement, just like what we've been doing all unit. So transitive, you transition the middle guy out. So in the transitive property, you transition out the middle guy. So if A equals B and B equals C, means I can transition out the B, okay? So that means that A equals C. So what this is, so let's say X equals 3. And then we also know that 3 equals Y. Then, so if X equals 3 and 3 equals Y, then we know that X equals Y. X is 3, 3 is Y, so X equals Y. We just transitioned out my middleman here. This was one we did, okay, when it snows, I wear my gloves. When I wear my gloves, my fingers get itchy. So that means when it snows, my fingers are going to get itchy. And I just transitioned out the gloves part because I know it's just going to be true. And then we also know our simplifying, combining like terms, using order of operations on a single sign. So like if you see, you know, if 3x plus 4x, then 7x, right? They equal to each other. Combining like terms. Now, these were all POEs. POE, property of equality, property of equality, property of equality. Those are all POEs because these are all equal signs, y'all. Equal, 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 equal. The only time it's going to change is it's going to be a POC, property of congruence. But the words stay the same. So like reflexive property of congruence, reflection is the same either side. So AB equals AB. Let me come up with an example of that. So if you've got a line with a midpoint, that's a midpoint. So AB like that. I know that AM is equal to AM. Doesn't matter if you see this statement, that is the measure of, or I can even do it with angles too. So like, A, B, C, so angle A, B, C is congruent to angle, what about we say CBA? That's probably more when reflexive is used, when you just change up that order. Symmetric. Symmetric we had in purple. Symmetric means that you can flip it like a mirror. Flip it like a mirror. Your mirror, your symmetric, you have your symmetry, lines of symmetry. You can fold it in half and it stays the same. So AB is congruent to DE. DE is congruent to AB if it just wants the order changed. Transitive, exactly the same. So I know that if I can transition out my middleman and end up with my two ends being the same. So these two guys are equal to each other because I transitioned out my middleman. We only use the congruent symbol when it is letters and symbols, right? So here I've got a lot of segments. We only use congruence with segments, lines, angles. We do not use congruence with numbers. Name that property. Write the name of the property that justifies each statement. All right, if K equals 3 and then 3 equals K. So let's see, which one means that you can switch them? That's the symmetric. That's the symmetric, P-O-E. Great. Okay, here, to get from 2x equals 14 to x minus, or x equals 7, divide by 2, divide by 2. Which one says that you can divide by both sides? Division. Property of equality. It's an equal sign. I know it's a POE. All right. 10A equals 2B. 2B equals C. So look, we have a middleman that we transitioned out. So that is my transitive POE. Here it looks to me like we distributed, so that's my distributive POE. Property of equality. This one, normally you're going to see congruence there, but this is the measure of AB equals the measure of CD. So they used equal, so we're going to keep equal. And it looks to me like they added EF to both sides. You can add something to both sides. Addition. property of equality. We're going to leave it property of equality because it's an equal sign. But here I've got some congruent symbols, and it looks like they just flipped them. So flipping them is the symmetric property of congruence. If A is B, C is B, then A is C. We transitioned out this middle guy. We transitioned out the B, so that is my transitive property. Property of, and we're using the congruent sign, property of congruence. All right, when something equals the other, that's just your reflection, y'all. Reflexive property of, that's an equality. Oh, what's happening here? They simplified it by adding 1 to both sides, right? So you add 1 here, add 1 here. That's how you got rid of the 1. So that is adding 1 to both sides. Excuse me. Addition. Property of equality. Here, what do they do? I have a 6 and a 6, so times 6 here, times 6, like this one was +1 and +1, is going to be multiplication. Property of equality. Whew, big sentences here. Let's see, what looks the same? It looks like I've got K and 4K, 5 and 5, 3K.
Penny Jordan, you are needed in your mom's office.
Oh, they combined like terms. So K plus K equals 4K, 3 and 7 equals 10. So that's just combined like terms. And we could use POE here or not. Don't know why that one doesn't have that same rule. What is happening here? R plus TU equals X. Okay, we're going to sub on this one. So instead of TU, they wrote WV because I know that these two are equal to each other. So they just substituted in, instead of TU, write WV. That is the substitution property of equality. Measure of angle ALB equals measure of angle ALB, y'all. Same thing, both times, reflects. Reflexive property of equality, yes. And then again, equality, if measure of angle A equals 1/2 that. So then they said times 2 on this side, times 2 on this side, so that is just multiply. I have a quizzes of this, or a Quizlet of this, that you're really going to want to use. Most of these make sense. The hard ones are reflexive, symmetric, and transitive. All right, so use the properties on page 1 to complete each statement. So this one, it gave you the reason. You have to finish the statement. Here, we gave the statement. You gave the reason. So subtraction POE means that we're subtracting 3 on both sides. So it's then X equals 21 minus 3 is going to be 18. That is the subtraction POE. Transitive means we're going to transition out my middleman. So we're going to transition out that ST. Means that RS equals TU. Symmetric means that I can flip them. So if 5x equals 10, then 10 equals 5x. Reflexive just is the same thing twice. CD equals CD, dunzo. Symmetric, I can flip them. So LM is congruent to JK. All right, this one, transitive. So I know I'm going to transition something out here. So 1 plus 2 equals this. And this equals this. I would almost call that substitution instead, but yeah, sure. Then measure of angle 1 plus measure of angle 2 equals measure of angle FGH. I transitioned out that ABC. I think that could also be substitution and you'd be fine with it. So let's see, here's a substitution one. So 7 minus 8 equals 180. 8 equals 9, so that means I can get rid of that 8 and replace it with a 9. So measure of angle 7 minus measure of angle 9 is also going to equal the measure of 180. And then subtraction POE means, let's see, what are we doing? We're subtracting 90 from both sides. Minus 90, minus 90. Measure of angle 5 equals the measure of angle Q. All right, homework. If it gives you a property, give it the name. If it gives you the property, then complete the statement. These are the beginnings of proofs, which are what we're going to do next.